So first things first, let's go to Xcode.
Xcode. Xcode.
Go into the project manager,
Show project
and
navigator.
as usual, what I've done is I've already pre-coded all of the code, and I'll give you the step-by-step instructions with each of the different new files. This is pretty much a continuation of tutorial 3. So what you're going to do is you will add something called an audio layer.
Tutorial 4. Project. Assets audio layer.swift. Swift source.
Right, so it's just, contextual menu M, new file, Swift, and then name it audio layer.
Move focus to editor ellipses.
So the audio layer is another extension to the game view controller. We'll be putting some of the properties required for the audio layer down the track. On this one, we'll just populate the functions and everything for this extension.
// audio / new import foundation.
So, it starts by default by, including the foundation module, but you'll add the scene kit and the AV foundation module as well as the Coco module.
Import AV foundation. Import scene kit. Import Coco. New line.
Okay. Declare this file as extension game view controller.
Extension game view controller. Left brace.
All right. Now, once we're inside, obviously we can't put any properties because it's an extension. All the properties remain in the game view controller.
New line.
So the first thing we're going to do is to wire the system. So wiring the system meaning we're taking the audio engine out of the game view, saving it as a property at the requisite moment, and then we're going to do a few configurations inside.
Func wire system left parent right parent left brace.
So func wire system.
Unfold method.
So this is a function that's going to be called in the game view controller.
Speak player equals AV audio player node left parent right parent.
So the first thing, speak player equals
Func speak player equals AV audio player node left parent right parent.
AV audio player node. So instead of it being a SCN audio player, it's an AV audio player node. So it's a subclass of AV audio node, and it says player. That means it's meant to actually play some sound, and this is going to be placed inside your engine.
Let format equals.
Now this time I'm setting up a format which is an AV audio format, and this format pretty much persists throughout for each of the players. That means depending on what kind of file you may have AIFF, .mp3, mp4, you might have some WAV files and everything. Just double check what kind of format it works in, and usually the format is sample rate, if it's interleaved, usually in channels. Usually you want to keep it mono, obviously, to make it 3D positional. And also there's another thing, which is you don't really need to know it, but it's a 32-bit integer, which is used as a floating point for each of the values of each of the samples. And by standard, it's 16,200, 21,400, and 44,100, I think. Those are frequencies, so it's in kilohertz, and that dictates the resolution or the detail of your sound, how good it sounds. So what I do here is pretty much instantiate an AV audio format.
AV audio format left parent common format .pcm format float 32.
PCA format float 32.
Sample rate 16,200 channels 1 interleave false right parent.
Interleave as false, and I put 16,200 because this is for the actual voiceover. I mean, there's no need to overkill, with too many samples per frame rate, frames per second, for such a thing as a synthesized voice. So that's why I leave it low. But usually, if it is not the format of your actual buffer or your sound file, it's going to either sound faster or slower. In this case, it's going to actually sound slower because I think VoiceOver's sample rate is at 22,000 or 22K something, and I put it at 16K.
Environment equals game view audio environment node.
Okay, so here I bring up the environment node, which comes from the game view, and the environment node sits between the main mixer node and the output. The output is your speaker, and so the environment does some extra calculations between the mixer. That's where all of the different nodes go into the mixer. You can equalize it, just set some samples to have a higher volume, others lower, and then it goes through the environment, which itself does the a 3D environmental positioning of all of your nodes relative to your listener.
Environment. Dot rendering algorithm equals dot hrtf.
Okay, so I set up the environment's rendering algorithm to HRTF. HRTF is it's an acronym for Head Related Transfer Function. This is a pretty advanced algorithm which is used in SceneKit in order to increase the realism of the 3D positional effect. You will hear that a bit later.
Environment. Dot reverb parameters. Dot load factory reverb preset. Dot large room.
Okay, so again on the environment node, I set up a reverb parameter and set a factory, a default factory preset, which is I set it up as a large room, I think.
Environment. Dot reverb parameters. Dot load factory reverb preset. Dot large room.
Yeah, so as a large room. So the reverberations of your objects, depending on the distance with the listener, will change dynamically. And it will make it sound as if you're in a large room. There are several other instances like cathedral, large hall, small room. There's even one called plate. It's a very metallic sounding reverberation parameter, but we'll keep it to large room.
/ configure the effects.
Okay, now we're going to start instantiating the effects.
Distortion. Dot low factory preset. Dot multi cell phone concert.
So we got distortion, which is a
/ configure the effects. Effects. Tab.
I'll just write down
Let
dist
equals
AV audio unit, and
AV
then
audio unit.
I'll go through the different types of audio units that exist.
Image. AV audio unit EQ. AV audio unit EQ.
So EQ equal
Image.
yep.
AV audio unit delay. AV audio unit delay.
So we got delay.
Image. AV audio unit effect. AV audio unit effect.
Effect, which is something where you really customize your audio unit, but that goes a bit further down.
Image. AV audio unit reverb. AV audio unit reverb.
So we got reverb.
Image. AV audio unit sampler. AV audio unit sampler.
Sampler is another one which is useful for taking notes. So you take a sample of a piano and then you can start creating notes and the scales.
Image. AV audio unit component. AV audio unit component. Image.
So
AV audio unit EQ. AV audio unit image. AV audio unit. AV audio unit. Image. AV audio unit component. AV audio unit image. AV audio unit generator. AV audio unit generator.
So generator, it generates a certain type of sound.
Image. AV audio unit time pitch. AV audio unit time pitch.
So you got time pitch.
Image. String. AV audio unit type mixer.
But what I'm using is AV audio unit distortion.
Let dist equals AV audio unit. Selected. Selection loop / distortion dot load.
So now I'm going to load a preset on the distortion.
/ distortion dot load factory preset dot multi cell phone concert.
So
Distortion.
dot
Period. Load factory preset.
load factory preset, which is the function.
Left parent.
And what's good sometimes when the types of arguments are known, and so they're pretty much type aliased, and the type alias allows you to just press a dot and you'll have the actual example, like the different types of factory presets that you want.
Period.
So dot
M multi cell phone concert.
multi-cell phone concert.
Right parent.
So this is the distortion
Right
preset,
parent.
but I
Multi
can
cell phone
set up
concert. Selection
other ones.
deleted. Period.
I'll show you the ones which exist.
Image. AV audio unit distortion preset. Drums buffer beats.
Drums buffer beats.
Image. AV audio unit distortion preset. Drums low-fi.
Drums lo-fi.
Image. AV audio unit distortion preset. Multi-broken speaker.
Multi-broken speaker, and so on and so forth. But I'll leave it to multi-cell concert for now.
Image. Multi-cell. Right parent. Distortion dot wet dry mix equals 20.0.
Okay, so the wet dry mix is how wet you want it, so how much force do you want, power do you want of the on the effect. So on your node.
Distortion dot wet dry mix equals 20.0.
So I put it at 20.0, so 20%.
Echo dot delay time equals 0.5.
So now I put up echo, which is AV audio delay.
Echo dot delay time equals 0.5.
So 0.5, this one is a floating point number, which means a half a second.
Echo dot wet dry mix equals 20.0.
And echo wet dry mix, set it up to 20%, same plan.
/ start adding audio unit effects.
So now we have to attach all of those units inside the audio graph. Now just a quick primer on the audio graph. Imagine an audio graph as being one straight line between your inputs and your output. Your output being a speaker and your input can be a microphone. And in between, you could put all sorts of things. So you could put a node, and between a node and the output, you can add different filters. And maybe on the filter, you can add a second node that goes into the filter and mixes and blends the two sounds together. And then that goes into another filter, which blends everything, goes through the mixer, and then onto the output into your speaker. So a graph is something like that. And a graph can pretty much theoretically hold a limitless amount of nodes, which is the only limitation being your computational power in your system. But pretty much, if you want to visualize it, set up a graph as a horizontal line. Left hand side are all the inputs. It can be a microphone, it could be WebSocket, so someone's sending you a message via Skype or something like that. And then the output is the speakers. That's when you hear it, and all the magic takes place in the intermittent horizontal line, where you can start adding more nodes in it.
Engine. Attach left parent distortion right parent.
So I attached the distortion and echo as well as the speaker.
Engine. Attach left parent echo right parent. Mixer equals engine. Main mixer node.
So mixer equals engine dot main mixer node.
Engine. Attach left parent speak player right parent.
So I got the speak player, and all of these get attached. They get placed in first of all. That's pretty much it's compulsory. You have to do it because you have to tell the graph that these exist inside, and they don't have to be connected because they can be connected and disconnected dynamically, just like a telephone switch. As you connect and disconnect the different jacks, like the old ones, then you can pretty much route a call from somebody into an office to someone else, and maybe you can attach 2 or 3 other listeners, so that 2-3 other people from other office spaces, can also hear the person speaking on the other side.
New line. Engine. Connect left parent speak player to distortion format right parent.
So in this case, what I want to do is I want to attach the audio player of all the voice synthesis coming from Alex, and I connect that first to the distortion audio unit. Then the distortion audio unit connects to the echo, and the echo finally connects to the environment, and then the environment connects to the output, but the environment is already inside and is already connected to the output. So what you're doing is chain linking between your audio player all the way up to the environment, which itself is connected to the output, and that's where all the filtering takes place.
Engine. Connect left parent distortion to echo format right parent.
And obviously the third argument for the connect, the engine, so AV audio engine.connect, the third argument is the format, and the format has to be the same from the start up until either the mixer or the output, because what you're doing is you're using all the audio formats of the initial source sample, so the source file, AIFF, MP3, and so on. If you don't set it up as that, then it's going to break the audio graph, and you're going to have some issues.
Engine. Connect left parent echo to environment format right parent right brace.
That's done.
New line. Func play audio left parent new line.
So that's pretty much with wiring the system, and it configures it, and upon startup. Now we go into the next function.
Func play audio left parent underline player FCN audio player underline node FCN node.
This is one that I used previously, but it won't be required.
New line. Func load speak left parent right parent dash new line.
So the second one is
Unfold method.
Load speak.
Func load speak left parent right parent dash AV audio PCM buffer left brace.
So the signature is func load speak. That's the name. Takes no arguments inside, and it outputs an AV audio PCM buffer. So it loads a buffer. It's a format called PCM, and it loads a buffer into an object, which is an AV audio PCM buffer. So that's what you will do every time you have a new speaking audio sample. You load it up.
Do left brace.
So here we're doing a try catch because the function to load an AV audio file does throw exceptions.
Let sound file equals try AV audio file left parent for reading URL.
And
do let sound file equals try AV.
Let sound file.
Let sound equals try. AV audio file.
AV audio file.
Left parent for reading. Space URL exclaim comma space
URL. So URL is, if you remember from the previous podcast, in the speech layer, every time, so the extension function, which is speak, every time you call that function, it actually saves to a file. And so this is basically the URL, the universal resource locator of that file. And it calls it from here.
URL, comma, space, common format.
So common format.
Space, AV audio common format.
AV audio common format.
Period. PCM format float 32.
PCM format float 32, which is pretty much the format that we're looking for.
Comma, space, interleaved.
Interleaved
colon,
false.
space, false, right parent, new line, new line.
So that is the AV audio file which has been loaded.
Speak buffer equals AV audio PCM buffer, left parent PCM format colon, sound file.
So now, sound file, which is the AV audio file, its format will be used for the buffer.
Speak buffer equals AV audio PCM buffer, left parent PCM format colon, sound file. Processing format, frame capacity colon, AV audio frame count.
And frame capacity is the frame count of the sound file.
Left parent sound file dot length, right parent, right parent.
There you go.
Try sound file dot read, left parent into colon, self dot speak buffer, right parent.
All right. So now sound file dot read into the speak buffer. So what you're doing is pretty much taking the audio buffers and putting it into the buffer, which is called speak buffer.
Right brace catch, left brace.
And catch.
Right brace.
And you can put a print statement. You can do all sorts of things. Whatever you want to do, just put it inside.
Return speak buffer.
And here at the end, it returns the buffer.
Right brace.
And this is pretty much a helper method
New
when
line.
you're going to be playing each of the different lines of the speech.txt file. And so here's the next one.
Func play speak, left parent, right parent, left brace.
Play speak, signature, no argument, no output. Because all it does, it manipulates some sounds and places it into the audio graph and then plays it.
Speak buffer equals load speak, left parent, right parent.
So speak buffer equals load speak. So that's the buffer with the function used previously.
Speak player dot schedule buffer, self dot speak buffer, colon, nil, options colon.
Now here,
Speak player.
speak player is the AV audio player node,
Speak player.
which is already connected into the audio graph.
Exclaim.
So
Period.
the exclaim is just to say that it's you guarantee that it's not a null value. Dot.
Schedule buffer.
So schedule buffer, that's the function.
Left parent self. Period. Speak buffer.
So speak buffer
Exclaim. Comma. Space.
at
Colon. Space. Nil.
nil, meaning that it will just start at 0, or you can just give a time frame at which point you want it to start. That's pretty useful for some more advanced mixing.
Comma. Options. Colon. AV audio player node buffer options.
So options, you can, this is another type alias, or it's a constant.
AV audio player node buffer options.
So it's AV audio player node buffer options.
Period.
Dot
Interrupts.
interrupts.
Comma.
So interrupts, you have interrupts and loops and interrupts on end of loop. And all of these options pretty much can control how your file can be played. And in this one, anything that has been played prior will be interrupted by this one.
Space. Completion handler. Colon.
Now completion handler.
Greater. Dash.
The completion handler is pretty much what you're going to do once the file has finished playing.
Right parent.
Okay.
Dash.
Here, dash
Greater.
And so the completion.
Right. Left parent. Left brace. Space. Completion handler. Colon.
So completion handler, that's
Space.
the label. And if you remember, the completions usually are in braces. And within the brace,
Left brace. Left parent. Right parent.
left parent, right parent, that means there are no arguments.
Dash. Greater.
Dash greater means what it's going to return. Void.
Space. IN. New line.
Void in. And so this is pretty much how it's written down. So it's left brace. It's as if you're calling a different function once your previous function is completed, and at that point you either set arguments, which are any of the objects you might have actually generated in the previous function. If you have any, you put them in there. In this case, there's nothing. Dash greater, and then what does it return? It returns void, and then in. And this is a swift way of saying, okay, well, this is the start of the block.
Current speech equals left parent. Current speech plus 1 right parent percent speeches dot count.
And here, once I've ended playing the first file, I go current speech, which is in this in the game view controller, which gives you the index of which actual speech text in the array of speeches you are in, and you increment it by 1.
Self.speech. Speeches. Current speech.
And here you call up the function speak from the extension speech layer with the new index, or the string that you extract with the index on the speeches array.
Right brace. Right parent.
And then right brace, right parent, because right brace is to close the completion, and then the right parent is because you've actually you finished calling the initial function, which has a closure itself.
Speak player. Dot play left parent. Right parent.
And finally, once that's done, you get the speak player to play.
Right brace. New line. Right brace. New line. Func dash return AVI. Func dash left parent left colon. S new line.
That's pretty much it.
New line. Right brace. New line.
However,
Right brace. New line.
I'm just going to add one little thing, and it's relevant to making things more readable.
New line.
So what I'm doing is I'm going to be overriding an operator, and the operator is going to be between two SCN vector 3 objects, and the first one is the position of the camera, so that means your position, and the position of the voice where Alex is going to be talking. The reason why I'm doing this is because once you start adding some filters, you need to actually control the 3D position of your listener relative to the node that you're actually listening to.
New line. New line.
So in that case, I need to actually set up a position every time I make a move with the control. Then I have to actually calculate the distance between myself and the node that I'm listening to, which is usually the node I'm listening to minus my position. And so this pretty much does it automatically, and it's nifty because you don't have to call a whole bunch of different lines in order to do it. You just do it with the operator, the plus operator or the minus operator.
New line. New line. Func dash left parent left colon. SCN vector 3. Right colon. SCN vector 3 right parent dash where AV audio 3D point. Left brace.
So func minus. So minus is actually the name of the function, which is the operator, and the arguments are left and right. Left and right both being SCN vector 3, and returns a AV audio 3D point, which is the one required for the AV foundation type objects.
Return AV audio 3D point. Left parent X colon. Float left parent left dot X dash right dot X right parent. Y colon. Float left parent left dot Y dash. Right dot Y right parent. Z colon. Float left parent left dot Z dash right dot Z right parent right parent.
So this pretty much instantiates an AV audio 3D point, which requires an X, Y, and Z coordinate, just like an SCN vector 3. But in this case, what you do is you actually coerce into a floating point number instead of a CG float. So a floating point number of the left.x minus right.x, and you do the same thing with the Y and Z coordinate, and then return it.
Right brace. Right brace.
So this is pretty much it for this file.
Save.